the end of our last video, which was the acids and bases video, I said that you can do any kind of calculations with acids and bases that you can do with every single other solution-based chemical reaction that we've been talking about so far. So you've probably had practice now using molarity calculations with dilutions. You've probably done some predicting of chemical reaction products. And we've done some stoichiometry and limiting reagent problems in class. So I'm going to go ahead and demonstrate a couple of different kinds of stoichiometry problems with acids and bases here. So a stoichiometry problem that you might see might sound something like this. How many grams of sodium hydroxide are needed to neutralize 45.21 milliliters of 0.6941 molar HCl. Okay, so look at the parts of this question. Just as usual, we're going to identify the A and the B and the start and the end of this problem. So hopefully you can start to recognize that the A is the thing that we know about and the B is the thing that we are asking about. And so when you read this question, when you read how many grams of NaOH, you can identify that NaOH is your B. And that when you read are needed to neutralize 45.21 milliliters of 0.6941 molar HCl, since we have all of the information about the HCl, that is our A. And then if you're going to plot out the progress of your reaction, well, the first thing you might want to do is actually write a balanced equation for this. So please make sure you do that. Sodium hydroxide is a strong base, and it's going to react 1-to-1 with hydrochloric acid to make sodium chloride and water. So when we look at our little flow chart, we can identify where we are for starting and where we are for ending. So when we start, we can see our A is HCl, and we have a volume and a molarity, which means we're going to start right here. And then we're going to end with grams of NaOH. And so now we can see the path that we need to take. So let's go ahead and set it up. So we'll start with our volume, convert to liters, and we do this because our molarity is in moles per liter. The molarity of the HCl is 0.6941 moles of HCl dissolved in 1 liter of solution. And now we're right to here. So we need to go to the moles of B now. We're going to use our balanced equation. 1 mole of HCl reacts with 1 mole of NaOH. And now we're right here. And we need to get to grams of B, so we're going to use the molecular weight. And if you calculate that, 1 mole of NaOH weighs 39.997 grams. And now we're ready to plug this into our calculator. So if you calculate that out, you should get 2.510 grams of sodium hydroxide that will exactly neutralize 45.21 milliliters of 0.6941 moles of HCl. So this is a straightforward stoichiometry question where we have one thing that we know everything about, one thing that we are asking about, and we just figure out how to get from point A to point B using our little flowchart map. So an example of a limiting reagent problem is really similar to this, except as always, limiting reagent problems will always tell you everything about both reactants, or two or more of your reactants if you have more than two. And they will ask about a product, or they may even just ask, what is the limiting reagent? So let's look at a problem. We might say something like, if 18.21 milliliters of 1.225 molar NaOH reacts with 15.25 milliliters of 0.8141 molar H2SO4, then how many moles of the sodium sulfate will be produced? So you should have enough experience now with limiting reagent problems that you probably can do this without consulting with me. So our first step is going to be to write the balanced equation. And then our second step is to identify our A and B, start and end, and then we're going to actually just do it. Okay, so pause the video and try this out. All right, so let's check your work. Sodium hydroxide reacts 2-to-1 with H2SO4. And so this is where it makes Na2SO4 and 2 waters. So when you do this limiting reagent calculation, you've got 18.21 milliliters and 1.225 moles of NaOH per 1 liter. And then our balanced equation has 2 moles of NaOH making 1 mole of Na2SO4, which means that we should have 0.01115 moles of Na2SO4 that are produced if we use 18.21 milliliters. When you do this same reaction, or the same calculation, but starting with the 15.25 milliliters of the H2SO4, you should get 0.01241 moles of Na2SO4 when you do this calculation. Notice that the NaOH has a 2-to-1 relationship with the Na2SO4, but the H2SO4 has a 1-to-1 relationship. So since this H2SO4 gives us a larger number of moles of sodium sulfate, that means that our sodium hydroxide was really the limiting reagent, and we're going to make this smaller quantity of moles. So the third kind of calculation that we've been talking about recently are titrations calculations. And titrations are just another stoichiometry. They sound a little bit different, but they are just stoichiometry reactions. So let's do another example. We might ask, what is the concentration of HCl if 3.914 grams of calcium hydroxide neutralize 37.16 milliliters of HCl. Okay, so once again, what's our steps, right? Write the balanced equation. Identify A and B, start and end. Pause the video and give this a try. Okay, let's take a look, see how you did. Hydrochloric acid reacts 2:1 with calcium hydroxide, and it makes calcium chloride and 2 waters. These are all soluble. So starting from our 3.914 grams of calcium hydroxide, we're going to use the molecular weight to convert this into moles. Oh, and I should notice, or I should point out here, that just because this calcium hydroxide is soluble, it doesn't necessarily mean that this is a solution. So I could use a solid, even though it can dissolve in water. I could still use a solid here and it would react with the HCl. So that's why grams is not a weird unit to use with calcium hydroxide. I might just opt to use solid calcium hydroxide. In a titration, what's often really common is that people will weigh out their 3.914 grams of calcium hydroxide before they do the reaction, and then they'll dissolve it in a little bit of water, and then they'll put the HCl in afterwards, just so that the HCl mixes better with the calcium hydroxide. But it really doesn't matter either way. You can get it to react either way. But I just wanted to clear that up. So we have 1 mole of calcium hydroxide, and we want to know how many moles of HCl it reacts with. So when we do this math, you should get 0.1057 moles of hydrochloric acid. Now the solution that you have has a volume of 37.16 milliliters. So this is our volume, these are our moles, we can calculate the molarity. 0.1057 moles of HCl divided by, convert your 37.16 into liters, and you should get 2.843 molar HCl. So if you do end up having any other questions, please just ask and we can go through some examples together.